Hi, Scott. How are you tonight?
Good, how are you?
I'm good. What can I do for you?
I had a question on 5.1. Let me see. Number 11.
All right, let me pull it up real quick, and I'll share my screen. Five point one, number 11. Almost there. All right, so here we go. Here is the problem. So we've got a function where we've got the outside temperature. I think I'm just going to copy this and paste it into. Oh, come on, you. Oh, my pen is not working as well as I'd like it to. All right, let's see here. Eventually I'll get there. Okay. Oh, here we go. All right. Okay. All right, here we go. So we got a function modeling temperature over a day. So basically, for any sinusoidal function, in order to write the equation, we need to know three things. We need to know four things. Sorry, we need to know the period. We need to know the amplitude. We need to know the midline. And we need to know the phase shift, which is just a fancy name with wave motion for the horizontal shift. All right, in this case, the period over a day, the period is 24 hours, which means if we do 2 pi over the period, that gives us the coefficient of x, or what in the formula is b. So oops, 2 pi over 24 reduces to pi over 12. The rest of them, the number gives us the direct number in the equation. So for example, the amplitude is half the distance between the high and low point. So if I say did 90 minus 74 divided by 2, and that would be 16 over 2, and that would be 8. That's the amplitude, is 8, in this case, degrees. The midline is halfway between the high and the low, or you can subtract the amplitude from the high point or add it to the low point. So in this case, if we said, let's say 90 degrees minus 8 degrees, that would be 82 degrees. The midline is a line, so let's write it as y equals 8. And in this case, they tell us the 82 degrees, that's the average temperature, and that's at midnight. That's my starting point. So in this case, since they give us the average, then we're going to say none. So we basically say there's no phase shift if they either give us the time of an average temperature, the time of a high temperature, or the time of a low temperature. So since they've given us the time of the average temperature, that should be y equals 82, not y equals 8. Since they've given us the time of the average temperature, we're going to use a sine, because the sine graph starts in its midpoint. Here's what a sine graph looks like, roughly. Starts at its midpoint and goes up to its high point. So this is sine. All right. So let's see here. So d in terms of t, so if we're going to write that as a function, it would be d of t equals, and then the amplitude is our coefficient of our function. And we said this is going to be a sine function, all right, and then parentheses, and then the period was 24 hours, which gave us our coefficient of x of pi over 12. And since there's no horizontal shift, I can just multiply that directly by x. And then I add the value of the midline, because that's basically the vertical shift, 82. All right, so the only thing left is actually the fact that the sign I've drawn isn't actually what's going on. All right, because at midnight, temperature is not increasing. Temperature is probably going down at midnight. So instead of being at the average and going up, it's actually at the average of going down. So the graph of this temperature function actually looks like this lower graph I've drawn, which is actually, it's just a negative sign, because if you to reflect a graph on the y-axis, you just multiply by negative. So my final answer is actually just going to be take this and put a negative in front of the 8. That's a big dash there. There we go. So -8 times sine of pi over 12x, and then plus 82. And that's my answer for this one. So you, if there had been a phase shift, which there is, I think, on number 12, then you just do a horizontal shift. So let's take a real brief look at number 12. Oh, come on, you. There we go. Oh, come on. Let's see if I can. I'm gonna move this to the other. No, there we go. All right. Let's go to 12. So at 12, it tells us when the low temperature occurs, which is at 8 a.m. So if you know the low temperature, so normally cosine starts with a high temperature, a high value, but if you know a low value, you can just call it a negative cosine. And since that low occurs at 8 a.m., you can do a negative cosine that has a right shift of 8, so that the low point would occur at 8. So you would just do an x minus 8 in your formula to shift it right 8 units. All right. Okay. Did you have other questions from 5.1?
Not from 5.1. I had one from 5.2.
Okay, let's take a look at that then. Let me pull that up. Oh, I was already there.
What I had done from number 11 is I used a cosine.
Oh, okay. Oh, yeah. So if you're starting at a midpoint, the average, you're going to use either a sign or a negative sign, depending on whether you're at that midpoint of the graph going up or going down. Okay. All right. And what question do you have in 5.2?
Let's see. It starts at number 6. I'm just confused on the tangent and cotangent graphs.
Okay. A lot of people are. So here's basically what I say. And in this case, it actually is shaped the right way. So if we think about, in fact, I'm going to pull up a Desmos window real quick and take a look at each of these graphs and the standard graph without any shifts or anything. See, I just want to make sure my battery's not going to die on me. All right, so let's do here. It's not going. I don't think I'm going to get what I need here. I'm trying to not pull up my keyboard. They don't have an. Yeah, tangent x. Okay. All right, so there's my graph. Let's just make I'm going to make the steps pi over 2 maybe. All right, let's see, where's my pi? Pi by 2, okay. There we go, that's a pretty good graph. Let me get this thing out of the way real quick. All right, so here's my graph of tangent. Okay, so the things to note about tangent are that it passes through the origin. Okay, this is an unshifted tangent graph. It has asymptotes at negative pi over 2 and pi over 2, and that's because it's sine over cosine, and cosine is 0 at those two values. Also, extra important are the fact that it is equal to 1 and to negative 1 at pi over 4 and negative pi over 4. In fact, let me change my scale to pi over 4 instead of there we go. All right, so now you can see that at pi over 4, it is equal to 1, and at negative pi over 4, it's equal to negative 1. And that's because the sine and cosine are equal to at those values. And note that's halfway between its midpoint and its asymptote. Now let's add cotangent to this. Cotangent of, where'd you go? There's my x. Oops, except it's out of the parentheses. There we go. And let me turn off my tangent graph. All right, so here's cotangent. Now its asymptotes are instead at 0 and pi. It goes down, but it's still at its midpoint, it's on the x-axis. And if you go halfway to either asymptote, it's 1 or negative 1. So cotangent of pi over 4, cotangent as cosine over sine, is 1 because cosine and sine are both square root of 2 over 2 at pi over 4. All right, so what this means is whatever the value, however much you've gone up or down from the midpoint, halfway to the asymptote is your stretch. Another thing to note here is that basically what I do is I always decide if my asymptote is 0, then I make it a cotangent. And if it's going the wrong direction, I just multiply by negative. And if the asymptotes are the same distance on either side of 0, then I make it a tangent and just multiply by a negative if I need to. So now let's go back to the graph we had. Okay, so this clearly has an asymptote on the y-axis. So that means I'm going to call it a cotangent. So even though it's, let's see if I can, let me see if I can. Oh, huh. It's not letting me, let me see if it lets me do this as an image. I'm trying to copy this image into, oh, weird, huh? I thought it would, well, let's see if I can pull this graph into somewhere I can write on it. Okay, let's click here. All right, I'll be able to draw on it here. All right. Okay, so, except I need to move this. Okay. So I'm going to add a few things to this. I'm going to draw in my asymptote. There's one on the y-axis. There's another at pi. So what's important about that is that tells me the period. Where my asymptotes are, as my period, is pi, which is what it normally is. So that's the normal period. So my b equals 1. So for unlike sine and cosine, for sine and cosine, the b is 2 pi over the period. For this one, it's pi over the period. Well, pi over pi would be 1. If it's the normal period, you haven't stretched it at all horizontally. But let's look at the midpoint between the periods. That's right at pi over 2. Notice instead of being at 1, it's at negative 1. That means that there's a negative 1 vertical shift. So that means there'll be a minus 1 at the end of the formula. So the next thing I do is I go halfway to my asymptote, and I look at how much I go up to my point. And in this case, it's 4. Well, remember, normally that difference was 1. It went from, on the unshifted cotangent graph, where's my Desmos? There it is. On my unshifted cotangent graph, it just went from 0 to 1. So here, since it went up 4, that's my stretch. So my vertical stretch is 4. And it's going the same direction as cosine. It's going down left to right. And it has an asymptote right on the y-axis, so I don't have to do any horizontal shift. So the period, the horizontal shift are normal, but there's a vertical stretch and a vertical shift. All right, so this is going to be y equals, or f of x equals. So there's a vertical stretch of 4. This is a cotangent because it has an asymptote on the y-axis. Positive because it's going down left to right, just like cotangent normally does. The period is normal, so I can just say x. But then it has a -1 vertical shift, so I put a -1 next to it. Now, the number one thing that I would say here is what makes this way, way, way easier is if you make yourself really, really familiar with the basic graphs. So if you know this cotangent graph really well, that's going to help you. And if you know the tangent graph really well, that's going to help you. If you don't know those graphs, it's pretty much impossible to do these graphs. I was going to go back to that. There we go. Where did we go? Okay. All right, so we can even just, I didn't do it on the last question, but we can put it in here. I said this was 4 cotangent of x minus 1. All right, so that works. And so let's see, here's another one. This also has an asymptote on the y-axis, so I would call this cotangent. But this time the period is 2. Because the next asymptote is at 2. All right. Let me actually, again, grab this one so I can sketch on it as well. All right. Okay, so if I have an asymptote on the y-axis, and I have an asymptote at 2, that means my period is 2. So my b, my coefficient of x, is pi, the normal period, over that 2. So that's all I need there. Because the midpoint is right on the x-axis, there's no vertical shift. Since I have an asymptote on the y-axis, there's also no horizontal shift. Oops. As long as I use cotangent. And this one's going the right direction for cotangent anyways. And then now the last step is to go halfway to my, and this is a little tricky because I can't see exactly where it is, but go halfway to my asymptote from my midpoint and try to go up and see where I hit the graph. And it looks like it's at 4. So my vertical stretch here is 4. So in this case, it was a cotangent. 4 times the cotangent, because that's my vertical stretch. And then my b was pi over 2. And you multiply that by x. There was no horizontal shift, so I don't have to add or subtract anything to x. No vertical shift, so I don't need a plus or minus at the end of my function. All right, and so this was 4 cotangent of pi over 2x. And that's what it looks like I want. And it likes that. All right, is that helpful?
That is, thank you.
Okay, excellent. So I'm just I'm kind of curious to see if the last one, yeah, this is, so this one, notice this one is going up from left to right, which is the normal shape of tangent.
Right.
But because there's an asymptote on the y-axis, I would use a cotangent just multiplied by a negative to flip it upside down for this one instead of a tangent. I always base my whether to use cotangent or tangent based on whether the y-axis is an asymptote or whether the asymptotes are the same distance on either side of the y-axis.
Okay.
So this one, the asymptote is on the y-axis, which is like cotangent, not like tangent. Because here's tangent. The asymptotes are negative pi over 2 and pi over 2. Whereas cotangent, the asymptote is on the y-axis. So yeah, that's how I choose. This one has the same period as the last one, though. Period is still pi. This one is shifted down 1. And if I'm looking for the stretch, my look at the stretch is it looks like if I go halfway to the asymptote, I go up and down, I'm thinking 3 units. Looks like 4 is a little too far over. It's more than halfway to the asymptote. So I think the vertical stretch on this one is 4. I mean, it's 3 rather. So when it's not right on a vertical line, it's a little trickier to tell, but it's still relatively straightforward to figure out where halfway between 1 and 2 is, say, for example. All right, anything else?
That's it. Thank you.
All right, you bet. Let's see here.